Let's practice implicit differentiation. We're going to find dy dx for the function x to the 10th plus 4x plus 6y to the 6th equals 15y minus 3. So our first step is to just take a regular derivative, which means for each x term, we're going to take derivatives normally as we would have all semester. And if we take the derivative of y term, we just need to put a dy dx next to it. So starting with the derivative of x to the 10th, bring down the 10, subtract 1 for the new power. So 10x to the 9th. We have the derivative of 4x would just be 4. We're taking the derivative of x terms, all as typical. But now we have y to the 6th. So when we take the derivative of y to the 6th, we will still bring down the power, 6, subtract 1 for the new power, and get 5. But we need to put a dy dx next to it. We took the derivative of y with respect to x. Equals, now I need to take the derivative of the other side. On the other side, we have the derivative of 15y. The derivative of 15y would just be 15. Just like how the derivative of 4x was 4, derivative of 15y is just 15. But we have to remember that we took the derivative of a y term. So derivative of 15y is not just 15, it's 15 dy dx. We took the derivative of a y term with respect to x. And our last piece is a constant. The derivative of negative 3 is just 0, which we don't have to write in there. Now that we've taken the derivative, we are going to solve for dy dx. This time I'm going to get dy dx on one side by moving it over to the right. It looks like I would have to move less terms to have all the dy dx terms on the right instead of the left here. So I'm going to go term by term and decide should I keep it or move it, knowing I want all dy dx on the right. Anything without a dy dx, I'm going to stay on the left. So should I keep or move this first term? I should keep it. I have 10 x to the 9th. It doesn't have a dy dx, and I want all of those on the right, so I'm going to keep that to the left. Same thing with the next term. I'm going to keep that 4 right where it is. But the next term, 6y to the 5th dy dx, I said I want those all on the right, so I'm going to go ahead and subtract that over. I'm going to subtract over 6y to the 5th dy dx. That way it's no longer on the left. On that right-hand side, I'm going to keep that 15 dy dx, and I subtracted over 6y to the 5th dy dx. So now we have combined like terms. We've put all the dy dx to one side. It doesn't matter whether you solve to the left or the right, by the way, both are going to give you a correct answer. But I moved all the dy dx to the right and kept anything without it to the left. And now I need to solve for dy dx. And last example, we just got to divide by the coefficient. Here we have more than one dy dx term. So when this happens, we're going to do our favorite thing from algebra. We're going to factor. We're going to try to get that dy dx by itself by factoring it out. This is like our nicest factoring in all of calculus, though. What we have for our factors are whatever those coefficients were. So dy dx was multiplied with 15 for that first term, and the second term it was multiplied with a minus 6y to the 5th. On that left side, I'm going to keep that 10 x to the 9 plus 4, and on the right side we have dy dx factored out so we can get it by itself, and it was multiplied with a 15 and a minus 6y to the 5th. Now my last step, now that I want to get dy dx by itself and it is just multiplied with a couple of coefficients, to get rid of multiplication we're going to do some division. We're going to divide both sides by that 15 minus 6y to the 5th. So our dy dx is going to be 10 x to the 9th plus 4 over 15 minus 6y to the 5th. Again, when your problem starts with x's and y's mixed together, your solution can have x's and y's mixed together. And there's one of the correct answers. If we solved it to the left, our answer would look a little different, but it would also be correct. There's a bunch of ways to write these. You could write 4 plus 10x to the 9th in the top, and it would also be correct.